Right, good morning, everybody. Good morning, grade 10. Let's continue EM with the discussion. Charles, all right? Okay. These are P waves and S waves. We're already done with the P wave and S wave. Okay, again, P wave travel faster or the fastest one. So it reaches the surface of the earth first after to be followed by S waves. P waves travel in both solid and liquid, so it can actually travel both lands and oceans, while S waves travels only into solids, meaning it will not actually travel in your ocean or bodies of water. An instrument that detects and records the ground motion from an earthquake is called seismograph or seismograph. Okay, seismograph or seismograph, still the same. Okay. And the record is called seismogram or seismogram. Please get your notes and write the important details. Seismographs or seismographs consist of heavy mass suspended on the spring and rotating drum that records the motion. Okay? The drum is anchored and moves on the same way as the ground. During earthquake, the suspended mass remains at rest because of inertia. Remember inertia? What is the concept of inertia again? Grade 10? This is actually the lesson of grade 9. This is the first law of motion by Newton, the law of inertia. So what is law of inertia again? Okay. Any idea, grade 10? Right? How about others? I will not let you pass my subject if you are not familiar with the concepts. Because again, I am training you with all of this. This is the main reason, okay? Or this is the problem of grade 10 for the students here. You tend to forget your lessons. It's the problem. And remember that these are continuations. Okay? The lessons of grade 10 are the continuations of your lessons from grade 7 down to grade 9. Okay. The first law of motion by Newton is called the law of inertia, which states that an object at rest remains at rest, an object in motion remains in motion unless acted by the unbalanced force of external force. What is that? Okay, so because of inertia, okay, the suspended needle there will remain at rest while the drum moves on the ground. Okay, the pen attached to the suspended mass and touching the paper on the drum traces out waves as drum moves back and forth. What are you doing? Okay, just like a paper with a pen. Okay, because the drum is continuously moving and the pen is just staying on its place because of inertia, there's no force acting on it, it will just stay on its position. But if there is a force that is acting on that pen, it will actually move. There are two kinds of seismographs. One records vertical motion and the other records horizontal motion. So we have two seismographs, actually, vertical and horizontal. Okay, modern seismographs use magnets to generate electric signals that are recorded by computers. Okay, because we are now using computers to analyze these seismic waves, okay, we tend to what? We tend to get more accurate information. We tend to get um more data out of it, computer generated. Okay, seismograph records the time of arrival of the amplitude of the seismic waves. Using the data on the latency of the different waves recorded by seismograph of different places, seismologists, it is a person that studies earthquake, okay, can locate the epicenter of the earth as soon as possible. This is the main reason why we can actually locate immediately the epicenter of an earthquake. Okay, again, because of this data. Okay, we have vertical, okay, and horizontal seismographs. Morning, Chris. You're too early for the next subject, Chris. Right. So you will now have an idea on what your project will look alike or your learning resources will look alike. Okay. You will have this learning resource material. Again, another one. Otherwise, you might be failed in my class. Okay. Again, your learning resource material would look like this. I will just post it in your LMS. It is actually created. Yes, you create one.
Learning resource.
So this is actually a pen. This one, okay, with a metal ball and a paper. Okay. And of course, a motor on the sides. This one. So there is a motor there moving. Okay, if there is no earthquake, the tendency is the pen will stay on its place. But if there are some movements or there are some external, okay, external movement, external force that acting on the needle, it will create what? A mark. It will move. So we will create an actual seismogram or seismograph that actually move. Problem with the motor.
Doesn't it go at a certain speed?
Oh, it should be slow.
Yeah.
There are a lot of motors that you can actually buy.
The motor,
Electric- Electronic shops.
I think like we use it, like it goes slow. They're just motors that are slow.
There is. I actually created
So
one.
it's based on
I actually created one before, which is, yeah, because of the spring, okay, horizontal and parallel. So if you're gonna use that one, you need to find a better spring. You're gonna use this one. Okay. Motor should be slow so that we can also check on the movement of your pen. What would be the problem? It is too fast. We cannot record something there because it's too fast. Otherwise, your needle or your pen will just move around. It will just bounce off. Okay, let's continue. The size of an earthquake is measured in two ways. We have two ways on checking on its size. Okay. This is measured in two ways. The number that indicates the relative size of energy released in an earthquake is called magnitude. Okay. It is determined to the maximum amplitude of the ground motion recorded by the seismogram. Okay. That's the magnitude. A single release of an earthquake magnitude is equivalent to 30-fold increase in energy released. For example, the energy release of a magnitude 5 earthquake is equivalent to explosion of 1,000 tons of TNT. I need to learn explosive TNT. Okay, while the magnitude 6 earthquake is the energy equivalent to 30,000 tons of TNT. TNT is actually an explosive device. It is not, it is an um explosive material. It's TNT. Intensity, on the other hand, is the amount of damage caused by an earthquake, usually denoted by Roman numbers. Okay? A large earthquake has a higher intensity near its epicenter than areas farther away. Because again, if the epicenter is located on top of the focus, meaning to say the source of an earthquake is above, okay? The source of an earthquake is in the focus, correct? So above the focus will be your epicenter. So the damage is greater than those areas that is far from the epicenter or the focus. So the first intensity scale is called the Mercalli scale. Okay, Mercalli intensity scale, MMI, developed by Giuseppe Mercalli in 1902. In the Philippines, PBOX earthquake intensity scale, PEIS, developed by the Philippine Institute of Volcanology and Seismology, is used in reporting earthquake intensities. First is the Mercalli scale. Okay, Mercalli intensity scale. And the one we are actually using here in the Philippines is the PEIS. Okay, the PBOX earthquake intensity scale. Why do we need to have our own? What do you think is the reason? Why do we need to have our own? Okay, let me check your knowledge. Why do we need to have our own? Grade 10? Why do we need to have our own?
I think it's
Because what?
culture. I think it's because earthquakes here are more common to where the first scale was invented. And at the first scale, they don't expect that much earthquakes, so we'll have more maintenance time, and ours will require less maintenance time.
Possible. Yeah, there is. The idea is there already. We need to have our own simply because Filipinos, take note, Filipinos will tend to ignore, okay, information from international sources. One good example is Typhoon Haiyan, Super Typhoon Haiyan. Okay, when we mention Super Typhoon Haiyan here, no one actually cares. International actually cares. But when we name Haiyan associated with the Typhoon Yolanda, so the people now what reacted. That's the main reason why. Because Filipinos are hard-headed. That's the reason behind. So we need to have our own. So that what? Filipinos will respond. Because if we're gonna use the Mercalli scale, they will not respond. What is that? We don't care. That is not ours. But in our science community, we tend to get idea. We tend to convert that one into our own dialect, our very own, so that Filipinos will what? Will understand, number one, and number two, will respond. That's the problem with Filipinos. Let's move forward. Deformation. Tectonic forces operating inside Earth cause rocks to undergo deformation. By the way, have you heard about the news that, again, another low pressure area is coming in the Philippine area of responsibility? Okay. So if that is the case, Filipinos will not respond unless it is actually given a local name. Okay, there you go. Pag-asa already given it a local name. It is called Paing. Bagyong Paing. Another term. Okay, but it has an international name. That's the reason behind.
What
Okay.
about Odette?
I don't know. It's already Paing coming in the Philippine area of responsibility. Well, it depends upon the speed and the humidity of that certain low pressure LPA. Okay. Again, tectonic forces operating inside Earth cause rocks to undergo deformation. Okay. It is a process by which rocks change in shape, size, location by location Okay, tilt or break due to the squeezing, stretching, and shearing forces. Okay, they change location because they are actually what? Eroded. Okay, they change location because they are carried by larger rocks, for example, or a landslide. Okay, it is the dominant process in the formation of mountain belts. Okay, please take down notes. Please take down notes, everybody. In physics, a force applied per unit area is called stress. Okay, that's in physics. If the forces act uniformly from all direction, it forms a uniform stress. If it is all in all direction or uniform direction, also referred to as pressure. Okay, the weight of overlying rocks exert pressure, referred to as confining stress. Okay, this is the rocks exert pressure. Okay, confining stress. I think we still have 2 minutes left. Okay, let's continue by next meeting. Okay, let's continue by next meeting. Hopefully we can discuss more. Okay, don't worry, we'll have a lot of activities, we'll have a lot of laboratory works to cover up your grade. And again, every meeting, because this is face to face, I might give you again a surprise quiz.
Science tomorrow.
No, can I borrow your student?
Yeah.
We have. We'll transfer.
All right. Okay. Again, I might give you a surprise quiz before we start the class. It could be we have actually assessment. We call that one as pre-assessment. Meaning to say, I can check or double check whether you study the lesson in advance or not. Supposed to be, grade 10 should be studying the lessons in advance. That's the reason behind. Okay. Are we okay? Are we okay? Don't worry, I will help you out with your grade. As long as you cooperate also.
The boys will carry on the. My picture.
Okay, I think we are done. Please stand for the prayer, Rabbi. Do not start unless everybody's ready.